Hi everybody, welcome to advanced concept number 2, iodine clock reaction. My name is Jeannie Moran and I'm going to take a little time to explain this presentation to you using some household ingredients. First, let's do a little review. The iodine clock reaction is a classic chemical clock demonstration. It's used to display chemical kinetics in action. First discovered by Hans Heinrich Landolt in 1886, many texts today still refer to it as the Landolt reaction. In this experiment, two colorless solutions are mixed. At first, there will be no reaction, or so it appears, and after a given period of time, the solution will turn dark blue. This time period where it looks like nothing is happening is called the clock period. And that's the amount of time that the mixture remains colorless until the change to dark blue will occur. In various other versions of this experiment, different things are changed up, temperature, amounts of solutions, ingredients, and that clock period is measured based on all of these various changes. This chemical kinetics is something that's used in many different areas, not limited to pharmaceutical, how drugs work in our bodies, and even like food chemistry. So this is actually an interesting advanced topic that we're going to try to go over pretty quickly today in a basic experiment. What I used for my experiment were two 1,000 milligram tablets of vitamin C, tincture of iodine, 2%, distilled water, 3% hydrogen peroxide, and cornstarch. So let's begin our experiment. So what I'm doing here is I'm taking my two 1,000 milligram vitamin C tablets and crunching them up in a glass. Once they become powder, then I am going to top them off with my distilled water and mix it up for about 30 seconds. And as you can see, as I mix this up, it is not dissolving into a clear mixture. In fact, you'll see unsoluble artifact all over and on the top of the water. So most of the pill is just filler and things that don't really matter if they're used in production. So what I'm going to do about after 30 seconds of stirring, and I'm left with this solution, is I'm going to take some coffee filters and a clear glass and a funnel. I'm going to run my fluid through the coffee filter. And as you can see, because I'm going to do it a little bit, speed it up so to not torture you all, but you'll see that a lot of the stuff, the white gunk, is going to be left on the top of the coffee filters. And that stuff is, again, just stuff that's used in production, fillers and the like. So after speeding ahead, you could see all the insoluble things left. I decided that I was going to refilter it one more time. So what I will do is dump the mixture into the coffee filters again, using a clean glass, and then pretty quickly relatively clear solution will come through. So when that is done, I will be setting that aside. And then I'm going to start talking ahead while you're watching the rest of this, because otherwise I'll run out of time. But when you see me with the cornstarch in a few seconds, what I'm doing is starting on solution B. So what I'll be doing is measuring out around a quarter to a third of a teaspoon of cornstarch. And then I'm also going to use about 350 milliliters of distilled water. And I'm going to start mixing up the cornstarch in the water. But again, you'll see a pretty cloudy solution. So in order to try to break down some of the cornstarch in that water, I'm going to take my glass of cornstarch and water over to the microwave and heat that up until it's boiling. Here we go with the cornstarch solution. So as you'll see that I'm mixing that up, and it's like when you make gravy, you have to heat it up to get the cornstarch to dissolve in the heated solution. That's kind of what I'm going to do now. I'm going to bring it over to the microwave and I'm going to heat it up. And when it comes out of the microwave, it'll be a lot clearer and there will be a lot less free-floating undissolved cornstarch in the top of that solution. But being a purist like I am still going to run that through a coffee filter just to try to get any little last chunks of cornstarch out of that fluid. And then once I do that, I'm going to set that mixture aside for now. And eventually I will come back and add about 150 milliliters of 3% hydrogen peroxide to this solution. And we'll mix that up a little bit. And then going back to solution A, there I am going to let that go through to get the rest of the cornstarch out of the top. Meanwhile, I'm going to go back to solution A and add my iodine tincture to my vitamin C solution that I had been filtering through the second coffee filter. So when you see me add the iodine tincture, you'll notice that it's very dark and very strongly colored. There it is. When I add it to the vitamin C solution, you'll see the color starts to disappear immediately. So I'm adding 2 bottles because that's just the amount I needed and the size of the containers they came in. I got those at Walgreens. So you'll see the mixture, after I swirl it up, it'll go back to being colorless. If this doesn't happen, it means I haven't added enough vitamin C. So to finish solution A, I'm going to come back and just top that off with about 500 milliliters of the distilled water. And then to go back to solution B, which was just over, meanwhile is draining through the coffee filters on my counter, then I will come back and add my peroxide on top of that mixture and also top that off with the rest so that I have about an equal amount of both solutions. So when A and B are, there I am adding the peroxide. When A and B are complete, then we're going to go on to the next part, which is the fun part. So having 2 clear glasses and having my A and B solutions, I'm going to add them together at the same time to my clear glass and wait for a color change to occur. Here I go. So I'm going to take A and B and I'm going to pour them into this tall glass, and some of you may be expecting a sudden color change, and depending on your variables you may see this. You might see a little bit starting there, but let's just keep watching while I talk. So I'm going to talk about what's happening here quickly. In solution A, we have a mixture of vitamin C, colorless I minus ions, and in the solution B we have hydrogen peroxide and starch. So what's the relationship between the iodine, starch, and the vitamin C? Chemical reaction is a process where elements or atoms in a compound react with each other and form products called reactants. Iodine can react with vitamin C and it can react with starch. When the iodine reacts with the starch or amylose, it forms a new substance that turns the water dark blue. When the iodine reacts with the vitamin C, ascorbic acid, the product that forms is colorless in water. If we add iodine to a solution that contains both starch and vitamin C, the solution will remain clear as long as the iodine is reacting with the vitamin C. When iodine has consumed all the vitamin C, voila, the solution turns blue as the iodine starts to react with the starch. When solutions A and B are mixed